Hello there, Algebra students. This is Mr. Kashi speaking. This is going to be our second of two videos on Chapter 10, Section 2, Day 1. We're going to be spending 3 days on this. I just want to go through 3 examples of how to find the axis of symmetry and how to graph parabolas that don't have a vertex on the y-axis. So just as a quick reminder, the axis of symmetry would be x equals the opposite of b over 2 times a, right? So we're going to take the equation y equals 2x squared plus 4x, and so this would mean that a is 2 and b is 4. So now we can plug this in to this formula. So opposite of b, so opposite of 4 would be negative 4 divided by 2 times our a, which is 2. So this would be a negative 4 over 4, which would be negative 1. So our axis of symmetry would be at x equals negative 1. There's 2 things that we have to do with that. One, very important, that has to be our middle number in our table. And we need to draw our axis of symmetry line right here, because we know that that is going to split our parabola in half. Then we would go 2 numbers, 2 values ahead of that and 2 values behind that. So that would be negative 2 and negative 3. And this would be 0 and 1. And then we can bring down our 2x squared plus 4x. So thinking back, again, the reason we put the whole reason we do the axis of symmetry is to make sure that these are the same numbers and that we can only plot 5 points. If we didn't know where our vertex was, then we'd have to be finding random points, just hoping that we find the vertex somewhere. So in this case, I'd like to plug in these bottom 3 numbers. That seems like the easier thing to do. So I'm going to go from bottom to top. I don't want to have to deal with the negative 2 and negative 3 if I don't have to. So here we're going to plug in a 1. So we have 2 times 1 squared plus 4 times 1. So 1 squared is 1 times 2. This would be 2, and then 4 times 1. 2 plus 4 would be 6. Now we'd pretty easily plug in the 0. So 2 times 0 squared plus 4 times 0. Well, anything times 0 is going to be 0. So we are going to be going through the origin, but the origin is not going to be our vertex. Then we plug in our negative 1. We have negative 1 squared, which would be 1. 1 times 2, this would be a 2. And then we have a plus negative 4 there, so this would be a negative 2. Now, since parabolas are symmetrical, we do not have to do the arithmetic for the top 2. We know that it's going to be the same. It's going to be mirrored as what we have down here, so that'll be a 0, and this will be a 6. So having that negative 1 in the middle really saves us a lot of time and to locate where our vertex is and to graph our parabola. So now we can take those points from the table, plot them here. We have negative 3, 6, go right there. Negative 2, 0. And we have negative 1, negative 2. So our vertex is right there on our line of symmetry. We have 0, 0, and then 1, 6, like that. So our parabola will look like this. So it is stretched a little bit, as you can see, because of the 2 in front of the x squared, but we moved it left and moved it down a little bit as well. So it's not exactly like our parent function. We just stretched it and slid it a little bit to the left and a little down. So I want to go through a few more examples like this, but go ahead and pause if you need to finish taking notes. So this next one, we have a 2x squared minus 8x. So once again, the first thing we're going to have to do is find our axis of symmetry, that's going to be the opposite of negative 8 over 2 times our a, which is 2. So that is going to be opposite of negative 8 is going to be a positive 8 divided by 2 times 2, which is 4, which is going to be 2. So x is going to equal 2. we need to bring that down into the middle here. And I have 2 right there. And then we can also come over here and draw our axis of symmetry line at x equals 2. Now what we would do is we'd bring this down, 2x squared minus 8x, and we'd make sure that we go back 2 values and forward 2 values. And once again, we can choose what we want to do here. We can either plug in the 0, 1, and 2, or we can plug in the 2, 3, and 4. What I would do is I would keep it easy and stay with the 0, 1, and 2. The smaller numbers, the easier the arithmetic. So here, I would plug in 0, and anything times 0 is 0. We don't have anything added on at the end. Then we plug in 1. So 1 squared is 1. 1 times 2 is 2. 8 times 1, so 2 minus 8, this would give us a negative 6. And then for our last one, we have 2 times 2 squared minus 8 times 2. So 2 times 2, so 2 squared would be 4. 4 times 2, this would be 8 minus 8 times 2 is 16. So 8 minus 16, that would be a negative 8. Once again, with our vertex in the middle, we don't have to do any more arithmetic. These will just get rewritten down at the bottom like that. That only works when the vertex is in the middle of the table, because we know parabolas are symmetrical. So then we can plot those points. We have 0, 0, which is the origin, but it is not our vertex. We have 1, negative 6 down here. 2, negative 8, that's our vertex because it's on our axis of symmetry. Then we have 3, negative 6, and 4, 0. So you can see how this is symmetrical. Our parabola lines up with our axis of symmetry. We're able to draw our parabola like that. All right. So obviously it's positive. It's stretched in the vertical direction by a factor of 2 because of the 2 out front of the 2x squared. We did move it. We obviously slid it to the right and slid it down quite a few, down to negative 8. This is where our vertex is. Go ahead and pause the video if you still need to take down some notes. But we have one more example here. So this is a trinomial. So we do have A, B, and C. We're going to find the axis of symmetry and then plot the parabola there. So here I would probably write out A equals negative 3, B equals 6, C equals 5, right? So we have the opposite of our B, which is 6, divided by 2 times our A, which is negative 3. So this is going to be negative 6 on top. 2 times negative 3 is negative 6. So this actually turns out to be 1. X equals 1 is our axis of symmetry. That goes there. And then we can draw our axis of symmetry right down where x equals 1. Once again, we can go 2 before and 2 after. So this is going to be 0, negative 1. And this is going to be 2, 3. And then we have negative 3 x squared plus 6x plus 5. Okay. I would still probably go with the top two. We're going to plug in these 3 values and not the bottom 3. In this case, doesn't really matter. You're going to come out with the same answer because these are going to be lined up. But I'm just going to stick with the top. So we have negative 1, negative 3 times negative 1 squared plus 6 times negative 1 plus 5. So negative 1 squared is 1. So this is going to be negative 3. Negative 1 times 6 is going to be negative 6 plus 5. So that'll be negative 9 plus 5. That'll be negative 4. And negative 3 times 0 squared plus 6 times 0 plus 5. Well, anything times 0 is 0, anything times 0 is 0, but then we have this plus 5 at the end, so we're going to have a 5 right there. And then finally we have negative 3 times 1 squared plus 6 times 1 plus 5. So 1 squared, it'd be 1. 1 times negative 3, this would be a negative 3. 6 times 1 is 6, so this would be plus 6 plus 5. So I would say negative 3 plus 6, that would be a positive 3, plus 5, this would be 8. And then we can reflect those down. We get a 5 and negative 4. So we just need to plot those points, and then we'll have our parabola. We have negative 1, negative 4, that's 1 point there, 0, 5, all the way up here, and 1, 8. And sure enough, our vertex is on our axis of symmetry. 2, 5, and 3, negative 4. Okay, and then you can draw your curve through your points like that. Sure enough, with the negative 3 out front, that means it points down. The negative means it points down, and we got stretched by a factor of 3, so that's making the parabola rather skinny. And then we have the plus 6 and the plus 5, which manipulate it. That means that our vertex is not going to be on the x-axis or the y-axis. So hopefully these 3 examples will help you. Your homework will be going through some more problems graphing these types of parabolas that don't have the vertex on the y-axis.